there is, Michael, I think, a risk that operators are not fully aware of what's there and what's available to them. And they'll still go and operate the machine. They'll get it to a certain stage where they're comfortable driving it, but might not be able to use the most of the facilities there to optimize its performance. So the combine manufacturers have to make sure these systems are easy to use. They have to make sure that training is available, but that training is really easy access.
Although the combine is only used for about 8 weeks of the year, the combine is a critical piece of equipment, and ensuring it's in good working order is vital for a successful harvest. Repair bills are often the catalyst to think about replacing the combine, but given the price of new or good second-hand machinery, the decision needs to be taken carefully. You're listening to the latest episode of the Tillage Edge with me, Michael Hennessy. We would really appreciate it if you could listen, follow, and give us a review on Apple or Spotify or wherever you get your podcast from. Combines have come a long way since the days of binders and thrashers. Today's machines are packed with cutting-edge technologies, offering on-the-move adjustment and features like GPS and grain yield monitoring. In this, the first of a two-part series, I'm delighted to be joined once again by Dermot Forristal, a researcher in Teagasc Oak Park, to discuss how the combine harvesters have evolved over the years and what the latest machines can offer farmers today. Dermot, by way of introduction, over the past 40 years, what did you see as the most significant developments in combine harvester design and performance?
I suppose the biggest thing really has been the pursuit of kind of scale in terms of working capacity. That's been a dramatic pursuit, if you like. In a way, if you think of it, all the main design features of combines have been carried over from thrashing sets. So that the basic concepts are very, very similar to what's been used for 100 years. But it's the way it's been implemented and the way that each of the components has been developed has been dramatic. And you've said over the past 40 years, well, even a little bit before that, there's been very dramatic changes. Because I can remember, Michael, back in the 60s and early 70s, combines didn't have cabs. They had 80 horsepower engines. They had 1 meter wide drums, 4 straw walkers. And even up to the early 70s, a lot of people had bagger combines. So they hadn't even got bulk grain handling.
And if we, Dermot, sorry to interrupt, if we go back even a little bit before that, and maybe our younger listeners might have seen them at some of the thrashing days, the old thrashers, as you call them, they were basically the same concept, a drum and a straw walker in behind them. So it really was just a fixed thing. It wasn't, the ultimate design today is probably not that different to the very, very first ones that were designed back 80 years ago.
Yeah. The basic design is the very same. The only difference is they combined it with the cutting element that used to be done separately before. So the original thrashing, if you like, you had the reaper and binder working in the field. You stacked it in the field, let it dry a little bit more, brought it in, put it in reeks, and then the thrasher came when it was ready, if you like. So there was one good element to it, I suppose, because what it did was it allowed the thrashing to be carried out over a longer period. Because when you moved all these machines and you combined them, which is where the name comes from, into one machine, then it had to have the capacity to do all of the work in the field within the harvesting window that's there. But conceptually, the components are quite similar.
As you said, the size has basically been a pursuit of size. And is that predicated by the size of farm? Which come first, I suppose, the chicken or egg? Do we need a bigger farm because of the bigger combine, or is it the other way around?
That's a good question, Michael. I suppose there's always been a pursuit of scale in terms of every machine that's there. In Ireland, you're right to ask the question, well, does that suit us? I suppose it always gives a reduction in labour, but it does mean the machines have to be used over a bigger area. So either the farms then get bigger, or you need a different mechanism of getting that machine used, whether it's contractor use or share farm ownership or something like that, something which we might come back to a little bit later here. But it's a very good question. And we follow two different paths, if you like, whether you're a grassland farmer. Most grassland farmers follow the route of contractor use, where it's tillage farming, where tillage machines are very central to the operation of tillage. They've taken the route of going for scale themselves to justify their own machinery.
I suppose on the other side of it then, Dermot, in terms of some of the rotary or maybe the hybrid type combines, has that technology added anything, or was the introduction of that technology probably more a case of this is what was available in the UK in terms of second-hand machines, and that was more of the main driver why some of those combines might have arrived in Ireland?
Yeah, well, look, there's a lot in there. Like if you take it, over the last 40 years, what's really happened, I suppose. Like the general development has been everywhere across the machine. So you've had things like hydrostatic transmissions being introduced. Um, you've had things like grain loss monitors. You mentioned then rotary combines because they did come in the 1980s, the first rotaries. And the first rotaries, if you like, all of the developments, if you think of it this way, a combine is constrained, a modern combine in its general format is constrained by the width of the machine that can go on the road. That's
Mm.
the biggest element that's there. And the conventional crossways drum it really kind of constrains that because the feeder house goes up between the wheels of the combine into the drum and it works from there. So you can't just keep making that wider and wider. So that was really some of the reason for trying to come up with an alternative way of separating the grain. Could we do it a different way? And longitudinal rotors came in. So the first rotary combines, if you like, the case axial flow, the New Holland TR machines, which really weren't sold in Ireland, the axial flows did come. They were designed as being machines that could, get over the problem of increasing capacity without making the combine physically huge in a way that you couldn't handle it on the roads. So that was the kind of design feature that came with those. But those original ones, weren't that suited, I suppose, maybe for damper harvests, maybe for countries that wanted to use the straw for use otherwise. I'm not saying they weren't suited at all. Like in North Dublin, for instance, and Louth, axial flows have been used successfully, and there's still some of them in use there, but they possibly weren't quite as well suited as some of the others. So what changed then really was that the manufacturers moved then towards trying to combine different elements of different machines. In other words, could we retain the conventional crossways drum, which seemed to work really well in the type of crops that we have? So most of the developments have been that way. And what started first was that people started adding maybe a second smaller drum or a rotary separator behind the first drum to increase its capacity rather than go wider.
Mm.
That then developed further, if you like, into true hybrid machines. And I suppose the one that people were most familiar with is the class Lexion, which was brought in the mid 1990s with a conventional drum, crossraised drum, but the straw walker element, that part was replaced by two rotary separators back going lengthways in the machine. So as I say, it evolved from there. As I say, true rotaries don't seem to be used in this part of the world too much, but we now have hybrid machines which uses elements of both machines, the traditional crossways drum, plus maybe longitudinal separation in place of straw walkers.
And the fact, Dermot, that we, I suppose, are very different in Ireland in comparison to most countries where we have essentially a very high biomass crop. And as you said before, that straw is fairly important to us. But, to support the big yields that we have, which are some of the highest in the world or the highest in the world for wheat, not all combine manufacturers might have that in mind necessarily when designing a combine. There might be maybe more for the lower biomass type, product going through it. So I suppose that comes into maybe what you're saying around the rotary element of it. That have they gone as far as they can go? I suppose is really where I'm trying to get to.
Yeah, no, I think the developments stay going. Your point is well made. There are different crops in different parts of the country or parts of the world. We have very high yielding crops in Ireland. I suppose what's more characteristic is that they're both high yielding, but also they can be harvested with relatively green straw, relatively high moisture straw, and relatively high moisture grain compared to other parts. Because if you think about it, the harvest index of grains doesn't change an awful lot. In other words, the ratio between straw and grain doesn't change hugely across the world, but the yield does, and how dry it is at harvest will. So your typical American prairie combine will have a huge header on it to try and get a decent amount into the combine, a decent amount of biomass into the combine, whereas our combines of the same horsepower, the same physical separation would probably have a smaller header because the header's taken in a lot more. But you're right, the finesses or the fine points about the design of the machine have to suit, the particular environments that they're in. And yes, Irish machines, the spec, if you like, of Ireland and the UK and this part of the world is to suit higher yielding crops, high volumes of straw, and slightly greener straw, and maybe the chance of a more high moisture harvest as well. Like what was really interesting though when you mentioned those things was the concept in the 1980s that came out for a while and used in some countries a little bit was that of a stripper header, which had the idea of not bringing most of the straw into the combine at all. In other words, you had a header that stripped off the grain and the heads, if you like, and largely brought head material into the combine. But to be honest, it never caught on hugely. It's used in some odd crops at various times because it really required a different combine for it, because you would have completely different ratio of grain to straw material coming into that machine. So the combine would really want to be redesigned to get the most out of the capacity there. But the idea there was then you cut the straw separately and you left that in the field or baled it, whichever you wanted to do, but not bring all that straw into the machine. But you're right, design is influenced by crop type and region.
And I suppose, like most new machinery, technology is becoming I suppose, a bigger part and feature on it. And you mentioned the sensors to detect grain going out the back being one of them, and probably they've got more, I suppose, sensitive maybe over time. You might be able to explain to me a little bit around some of the newer technologies that are available. I suppose, like there's lots of yield mapping and auto settings, and there's settings on the run and optimization of settings by the combine's internal jiggery pokery, I suppose. I don't really understand them all, but there's a lot of bits and pieces in a modern combine now.
Yeah, well, you've touched on them all there, Michael. To be honest, because in the past, I suppose the first thing that hits people, yeah, the first bit of electronics really were simple sensors that told you if things went wrong. If there's straw getting blocked in under the hood at the back, and so on and so forth. The next thing then was the grain loss monitors. So you had two sensors, if you like, at the back of the straw walkers and at the back of the sieves, and they were simple acoustic sensors in the beginning. So when the grain hit them, they gave a signal. So you had an idea if there was a lot of grain going back out over the back of the combine. Of course, what you didn't have at that time was something to equate that to your harvesting throughput. So once people saw a lot of grain going out the back, they said, "Oh, hold on a minute here, something wrong." And in some cases, there might not have been, because if there is a right amount of losses for a machine, it might be 1% or something like that. So those grain loss monitors need to become more intelligent, if you like, which they did. So your modern grain loss monitor actually expresses that in a percentage loss, which then you can then optimize your driving based on that quite well. But these things have gone, much, much further. There's a huge array of sensors on a machine. And you're right, today they can actually, you can really, automate the whole process, if you like, of optimizing the machine. So you can optimize the machine for throughput. In other words, it can measure the grain loss out the back. It can also measure the loading on the engine and so on. But so you can actually optimize the forward speed without the operator ever touching anything, that you get the maximum throughput through the machine. You can optimize for quality. You actually have systems today that have, a sensor, a camera type sensor looking at the grain quality. If it sees cracked grain, if it sees other material in it, it can change the settings of the sieves automatically. It can actually change the settings on some machines of the drum and the concave automatically. All things which you would have done yourself maybe, but would have involved a lot of checking, stopping, getting off the machine, looking in the grain tank, looking beneath the straw, and so on, maybe multiple times a day, which people aren't inclined to do. So this automation does have a benefit. Again, working on slope sensors, there are full hillside combines, but even on combines that aren't full hillside combines, they can change the distribution of material on the sieves to compensate for slopes, if you like, in a field as you're moving across the field. The same is true on the header of the combine. The height of the header, again, that's a huge benefit to have, that the header height is automatically adjusted. That's one of the earlier ones, but also the real height over that. And today you have systems that are scanning out in front of the header, looking to see what type of crop is out there and optimizing the header settings and indeed the combine settings based on the crop that's going to come into it in a meter or two's time in terms of forward movement. So all of these systems are available there to optimize the setting of the machine. And that's before you even considered the ones that are giving you management data, which is where your yield meters and your GPS positioning comes into play. So yeah, there's a lot in automation.
For all the things that you talked about, Dermot, and there is a lot there, and you probably need to be a very, I suppose, experienced person with all that technologies. But do you think people are getting the most out of them? Or maybe put it another way, are there some of those features that are underutilized by combine operators?
Yeah, I think that there's a risk of that. I think particularly in the early days of some of this, the people who would have bought machines with some of this on it would have probably used whatever was available quite well because they'd have went out there and they'd have sought it. Okay. But as it's become more standard parts of the machines, now some of this will work away in the background. You don't even know what's going on and it's probably optimizing to some extent. But there is, Michael, I think a risk that operators are not fully aware of what's there and what's available to them. And they'll still go and operate the machine. They'll get it to a certain stage where they're comfortable driving it, but might not be able to use the most of the facilities there to optimize its performance. So I think there is a trick there that the combine manufacturers have to make sure that these systems are easy to use. They have to make sure that training is available, but that training is really easy access so that if your driver changes next year or partway through the season, that it's really easy to interpret what's going on there. And some of the makers are quite good with this. They're giving you kind of visual aids of grain loss and things like that. That should be pretty intuitive to somebody who's anyway tech savvy at all. But I do think it's a good question, Michael, and I'm not so sure, in all cases that the benefits of the technology are being optimized in terms of just the running of the machine. Now, there's also other benefits, I suppose, from the data acquisition, but that's a different story. But there's problems there as well.
It brings to mind a couple of more than one farmer I've come across over the last while where their I suppose their parent or their father are still driving the combine, and they're very good experienced combine drivers, but all the bits and bobs and the electronics, they're not comfortable looking into that, and it's maybe somewhere where that a bit more training or help with setup could actually help maybe to get the best out of these expensive machines. But running on a little bit in terms of, and you mentioned at the very end where there's a capacity for lots of combines to use or the yield mapping to get the yield as you go along during the field data, so you actually have something at the end. Are farmers making any sort of use of that, or could they make a bit more use of that?
I suppose it's there since the dawning of precision ag, which was in the 1990s to some extent, that, the original notion was you went and you measured variability in yield, which a combine yield meter will do very, very well. Okay. So you measure that variability and instantly then there'd be a fix for that. In other words, you would cure that variability, if you like, and suddenly all of our field would be yielding 14 tons per hectare rather than just 10% of it. But that's where the challenge is, Michael. I think in most cases, there isn't an easy cure, an easy fix. In many cases, the variability would indicate that there are factors within the field, within the soil, within how, water table or water levels in that limit the yield in particular areas. So there isn't a potential to bring that yield back up. So the big question all the time is, if we're measuring, something like yield variability, what can we do with that? And I think that's still a challenge for a lot of people. And I think a lot of people got, I suppose, turned off a little bit maybe when they didn't see any great gain from it, because dealing with yield maps and so on wasn't that simple. You had to invest a fair bit of time in maybe downloading stuff from your combine onto a USB key, trying to decide what software you're going to manage that with and so on. So in fairness, the manufacturers have tried to make that a bit simpler. They're using telematic systems to transfer data so that the data from a yield mapping combine is often now collected via the cloud, if you like, and held on the cloud and is available to you probably for a fee, but available to you subsequently. So at least it has taken out some of the complexity out of that. But you still have the questions as to what are you going to do with that data? And I would suggest, we need to think simply first. The first thing is that it gives you is you're at least back to getting good yield per field data, because with big trailers today, as people move from field to field, you can even lose track of what individual fields are yielding, because you might have part of the field in the next trailer and so on and so forth. So at least it'll bring you that. But the basic yield variability that a yield map will give you should give you some indication, if you record that particularly if you do it for a number of years, should give you some indication of areas in the field that may be worth investigating to see, well, why am I getting different yield in those areas? Is it a soil factor that I can do nothing about? or is it a deficiency or something that I can do something about? So it at least lets you zone the field into areas of interest and areas that you might go and maybe do some soil analysis on the basis of the zones in those fields. You might go out and examine the crop on the basis of zones in those fields and start building up a little bit of knowledge that you might use later to alter the management within that field to some extent. So I think the expectations, as I say, Michael, in the beginning were very, very high. I think they need to be more modest, and they are. And but I think people, there is a lot of information can still be gained from those systems and can be used. And in the future, we will be able to probably read a little bit more accurately, go out and do that soil analysis piece with a much higher resolution than we can do it economically today. That will come about as both lab and field-based methods of testing soils are going to change over the next decade. So that will make the concept of precision ag a little bit more accessible to a lot of people.
We'll leave it there for this episode, and my thanks to Dermot as always for his in-depth knowledge on all things machinery. Don't forget to tune in next week where Dermot chats in detail about the factors around changing a combine, whether it's new or second-hand, or if the newer technology is worth purchasing. So finally, if you enjoyed the podcast, then recommend it to a friend or colleague, and as always, rate, review and follow on Apple or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy, thanks for listening. I'll be back next week with more tillage news and advice.